Alright, welcome to this talk, my presentation about improving OpenJDK on FreeBSD. It's been a project I've been involved in for almost 1.5 years now. Sponsored by the FreeBSD Foundation. So that's how I'm able to do this. But let's take it one step at a time. I'll go through a quick introduction and a bit about myself and a bit about the project and stuff. And also I'll talk about the BSD port project, what it is and how it's working. And I'll be talking a bit about my experience with working with the OpenJDK for FreeBSD project and how mainly how it's been working on the OpenJDK project and how it is kind of approaching and getting into a big and very established project like that. I'll also talk a bit about how we're planning to upstream the port, how we're approaching that, and a quick wrap up in the end. I hope I get time for everything, and if you feel I'm just rambling on, then tell me to shut up and get going. So, a quick introduction. First of all, this presentation is made by a human. Unfortunate consequence of the times we live, we have to specify this. It's quite depressing. But so, who is this human? I'm Harald, as I said. I've been messing around with computers since the early 1980s, and this is my first computer was a Dragon 32 with a whopping 32 kilobytes of RAM. That was quite powerful in its time, and it had a processor running at 900 kilohertz. So try to compute that. Of course, all the cool kids, they had Commodore 64s in those days, so they were swapping games and stuff, and since nobody else had the Commodore or had the Dragon like me, I had to learn programming instead, and that's how you end up here. I've also worked in the antivirus business in the late 90s, early 2000s, mainly intercepting file system and network traffic on OS2, a bit of Windows and Linux. I've been working on embedded high-end video conferencing equipment like this one. It's actually a bit interesting. I was trying to find this picture for the illustration and then kind of discover how the web has changed. Because it's impossible to find high-resolution images of this anymore. Because the web at the time was like designed for 800 by 600 screens or something. So it's a bit of an aside. I've also been working a bit in malware and vulnerability research. I've been doing a bit of web application firewall development, mainly with the rule sets and stuff. Done some penetration testing and security auditing, but it's not my main thing. At the moment, I'm now working on improving Java for FreeBSD. And that's what this talk is going to be about. First of all, as I mentioned, I'm sponsored by the FreeBSD Foundation. They are paying me to do this work, and I wouldn't be able to make these contributions without their help. So a big thank you to them. So, what is FreeBSD? It's a free and open source operating system. I expect most of you probably know this. It's derived more or less directly from the Unix, from the Berkeley software distribution that was for Unix in the early 80s, late 70s or something. It's licensed under a BSD license, mainly the BSD2 close license, I think, but there are some different variations in there. One of the things about FreeBSD is it's a complete operating system, not just a kernel like some other Unix variants. There's nothing good or bad about that. there's different approaches to do different things, and that's just fine. It's known for ZFS mainly, probably these days. It introduced jails that is kind of forerunner for some of the containerization that's become popular lately. I believe it's, or probably not FreeBSD, but BSD was where the TCP/IP stack was developed, as far as I can remember. It has no systemd. Again, to some people that's important, to others not so much. But what is always important, there's no payments. OpenJDK, it's a free software implementation of the Java virtual machine and language specification. It's stewarded by Oracle, but it's an open source project licensed under the GPL version 2. But we need to sign the Oracle contributor agreement. Especially if you, of course, you can just fork the project and you don't have to mess with that. You can just relate to the license. But if you want to get your code or contributions back upstream, you will need to sign the contributor agreement. There are probably many reasons for that, but one of them, I believe, is that Oracle also wants to produce their own proprietary commercially licensed JDK version. It's written mainly in Java actually, but large parts also in C++. There's some assembler and quite a bit of C. It supports a number of operating systems and also quite a number of different architectures. As you can see here, the upstream supported operating system at the moment is Linux, Windows, Mac OS, and AIX. I believe that's all of them. And a number of processor architectures. I'm not even sure I got all of them here. So, can anyone tell me what's missing from that picture? Good. All of the BSDs are missing. So, and that's what this project has been about. It's to try to make BSD a supported platform, or supported platforms. So that's what I'm going to talk about now. The BSD port project has actually been going on for a long time. It's a project to keep or to port and to keep OpenBSD, OpenJDK up to date on FreeBSD, OpenBSD, and NetBSD. Currently, I'm working mainly with FreeBSD, and there's another guy, Kurt Miller, mainly working on the OpenBSD side. But there are some cross-working, and we work together on this. It lives out of tree in a repository aptly named battleglobe/JDK on GitHub. So that's where we do our part and keep it up to date, and then it's sourced from there into the different packages that we have for the different operating systems. It's a collaborative project among the different BSDs. Yeah, so as mentioned, we were essentially 3 people in the project. There's Greg Lewis, who's the team lead, who's not that active anymore, but he is still involved and contributes. And there's me on the FreeBSD side and Kurt Miller and on the OpenBSD side mostly. He's also helping with some other stuff. He knows BSDs really well, so that helps me. That doesn't know BSDs all that. The goals of the project is first and foremost to make a solid port of the OpenJDK for the different BSDs. And the good part of that is this is mostly done. The port is quite mature and has been used in production for many, many years, and at the moment, at least the upstream port is fairly feature complete. The second goal is, and the main reason why I was contracted to do this work, is to include the port upstream and make it officially supported platform, make FreeBSD especially an officially supported platform for the Beastie or for the OpenJDK project. This is in progress. We have started working on the upstreaming part. It's a slow process, but it's going, and we, yeah, how to say it, it's, I feel we have kind of got some momentum, so it's going the right way. And it's being well received by upstream, which is also very important. The last goal, to pass the Java conformance kit test suite, is something that is probably not so much part of the overall BSD project, but it's one of the goals of the project I do for the FreeBSD Foundation. That is still pending. We have started looking into it. We're going to need to get access to the conformance kit test suite, and we have started working on that. So how is it? What is this like working on OpenJDK? This is going faster than I thought. Anyway, OpenJDK internals is it's complicated, as you can see. I thought one of the best illustrations for this was the merge bow by Kurt Winters. It's a fabulous artist you should definitely check out. He was one of the people who was too weird for the dollar movement. But OpenJDK, it's a big project, it's a huge project, and it has a long history, and it has a lot of code, there's a lot of history in the code, and some of that history you can of course see. And I'll get a bit back to that. First of all, it has a really complex build system based on autoconf and the GNU make. I'll talk more about that too. And as shown previously, it supports a lot of different configurations on many different architectures and on many different operating systems. There's a lot of details in the JDK that I'm not sure is that well known outside of kind of people who work with the code. It's like, well, everybody knows that Java is using garbage collection for memory handling, but maybe not everyone knows that you have, like, I don't know, 4 or 5, 6 different implementations of the garbage collection algorithms depending on the workloads you have and all of that stuff. And all of this is configurable during build time, which configurations you are supporting, and it's of course supported in runtime, so you can, for this process or this set of processes, you can use this garbage collections, and for this set of processes you use this other algorithm for garbage collection, and it all depends on the workloads of your process, which one is better for you. But they try to have, they have different performance characteristics and memory characteristics. And also there's the hotspot compiler, or hotspot virtual machine. It compiles Java bytecode into native machine code during runtime. But it also will still, it kind of have 2 different compilers. Also, one that is fairly quick, it just makes it fairly, it compiles the machine code, but it's not highly optimized machine code. And if you have a code block that is being used, a function or something that is being used very much, it takes, it pushing it over to a secondary compiler, which will then optimize the code further and make more highly optimized machine code for it. And there's lots and lots of these kind of things. There's lots of memory management stuff. Yeah. But on the good side, there's a fairly comprehensive test suite. Mainly it's using a tool called JTrake, which is a Java test regression framework or something. It's a custom test framework that has been developed specifically for OpenJDK. It uses some Google test, but I don't know how that's like going towards it or from it or whatever. It also has performance tests and lots of other tests too, so you can measure that your code is, or the changes that you do to the code is actually not hurting performance and not hurting features and not breaking anything. There is actually quite a lot of documentation, but never enough, of course. A lot of the documentation is focused more on, at least the one that's available on websites and stuff, is more on the processes and how to interact with the OpenJDK project and how to find the different groups within the project and finding mailing lists and all that kind of stuff, and how to kind of go about around the governance model and all of that. Other things that are good about documentation is that every commit to the upstream project needs to be associated with an issue in the issue tracker, the bug tracker. And while the commit itself is often a bit sparse on documentation, the bug issues that it refers back to often has more detailed information and rationale for why this change is needed or why this change is someone wants this change and what the goals for it are and stuff. Also, you have a process called the JEP process or Java enhancement proposals for bigger changes that will kind of span multiple commits, that is like a concentrated effort. You will have to submit a Java enhancement proposal that rationalizes why you want this change, how you're going to go about getting it, what your goals are for the change, what are the non-goals of the change, and then how you plan on keeping up with it or maintaining it for the future. There's lots of documentation, but it's not always easy to find it directly, but by digging a bit, you can pretty much find documentation covering a lot of it. In addition, of course, there's mailing lists and stuff, and if you ask the right questions, you can get quite interesting threads of explanations coming out of it. There's lots of really knowledgeable people in the project. It also has a very established government and development workflow, as is expected of a project of this size, of course. It's somewhat hierarchical, but it's also very consensus-driven. I don't know if there's much to say about it, but you kind of have to relate to it when working with this. There's also a large and, of course, helpful community. As I mentioned, the mailing lists are open pretty much to everyone, and they are usually quite happy to discuss and rationalize their reasons for doing things and helping you getting on the right ways. And I think, again, the illustration, Igor from the always helpful helper in the Frankenstein's laboratory, I think is a good representation of the community, always helping. And yeah, here comes the sea monsters. You're waiting for them, I guess. The code structure. It's, again, it's complex, but it's also quite easy to kind of navigate. It's sometimes hard to figure out exactly where what you're looking for is, but when you find it, you say, oh, that's where I should have looked first time. As an example here, just a quick look at parts of the hotspot code tree. The hotspot is, of course, the main virtual machine, and this is also where you find most of the low-level operating system and architecture code. As you can see on the side here, you have the CPUs, you have the operating systems, and then you have the CPU-specific code for the different operating systems. One of the interesting things you can notice here is that under the operating system you will find a BSD. And you will also find a POSIX. And that's quite interesting because the upstream doesn't really support BSD. But when it says BSD in the source tree here, that usually means macOS. Because macOS was originally derived from the BSD port, and they upstreamed it. And now, there's some code in there that we can use directly, but there's also quite a lot we have to make changes to. Sometimes quite large changes because Mac and the BSDs are nowadays at least quite different. Another thing to notice here is the processor architecture 0. That's a very important CPU architecture. It means there's no assembler or CPU-specific code for that architecture. So that is kind of like a dummy where everything is implemented in plain C or C++. And that can be good when you want to, I'll talk a bit about later, but it can be good when you want to move to a different architecture or kind of, you need to bootstrap things. Hotspot is mainly written in pretty C-like C++ and some assembler. Again, I think this is part of the history. Originally probably implemented in C and then has been moved to C++, but still contain a lot of the C-like structures around it. The build system is a chapter of its own. It starts quite traditional with an autocomp script to configure it. We get the pleasure of working with nice things like M4 and stuff like that. And yeah, there's not much to say about that. It supports a lot of different configurations and a lot of different operating systems, and so the configure scripts are also quite complex, but nothing you can't make your way through. The building itself is done by a rather complex hierarchy of GNU makefiles, and it has to be GNU make because these are not the typical makefiles you're used to, which sets a target and tells you how to compile the target. This is essentially just a collection of GNU make macros that, based on the configuration and what files are available in the file system and how things are organized, it generates the make rules in memory and then builds from that. It's quite hairy, but it works. And it's reasonably efficient. It may not be the way you want to make a build system today, but given the time and the history and how this has evolved, I think it's not easy to get around it, but it works. In addition, there's of course internal tools, mainly written in Java, that generates C and C++ code, or generates Java code, or even sometimes generate assembly code to kind of make different views of the world look the same. So you have the same constant if you write in the hotspot C and C parts, you have the same constants that you also have in accessible from the Java side, for example, and stuff like that. And also it generates a lot of stub code for the assembler, stuff like that. I mentioned the tests. The main test framework being used is as I said, JTreg, which is a separate project under OpenJDK, but it's a specially made test framework for OpenJDK. Part of the reason it's a special framework and not using something established is that when they started this effort, there was no, at least not good enough test framework that they could just plug into or use. It's fairly self-explanatory. You have these comment sections where you have tags that describe different things that are relevant for the test, like informational tags like the bug number and plain text summary of what the test is supposed to be testing, etc. Of the more interesting lines is the required lines, which here, for example, says that the test will only run if you're building or testing a virtual machine that has the serviceability agent present. And that's also one of the configuration options. The serviceability agent is essentially a debugging support for Java. It allows you to connect to a different JVM to debug it from your Java process. And also you can see it requires that it's not running on a RISC-V64 processor or not in QEMU. It will, it tells you where to find the libraries for the test and how to actually run it. And the test itself will be implemented in the class, typical like the one illustrated below here. You can have several of these text blocks or comment blocks that each define a test that all use the same test class, for example. It's not like a one-to-one thing here. As mentioned, there's some Google tests for especially for hotspots. I'm not really sure if they're on the way away from that or not. It seems to me, at least, like a lot of the tests that are run in Google Test is also duplicated in JTreg. The micro tests are a set of tests for like benchmarking and performance testing. Well, one of the things I wanted to mention is, if you look at the last line in the JTreg test description there, the run line, it doesn't make too much sense there, but it tells you that how to run this test. And in this case, it needs to run as a separate virtual machine from where the test framework itself is running, because it's going to connect back to the test VM, because it's testing that you can attach between two different virtual machines. But that's one of the requirements for the test framework, that you can kind of specify how the virtual machine that is going to run the test is going to be configured, which virtual machine it is supposed to be using. We're also using GitHub Actions for CI, which is a bit of a problem because GitHub Actions does not support BSD. So how we deal with that is that we are running CI for FreeBSD and OpenBSD on GitHub Actions by using a special action that installs a QEMU virtual machine in the CI runner of GitHub Actions. So it's quite slow and it's a bit fragile, but it seems to work good enough. In addition to hotspot and stuff, there's kind of the rest of the virtual machine, which is split into different modules. These are recognizable usually from the Java API docs. You have the java.base, java.desktop, java.awt, java.net, etc. Different. These are mainly written in Java, but as you can see in the example here, there's also some native code to be found sprawling around this place. And here you can see that macOS is actually called macOS. JDK is using it's using a number of different repositories. You have one main repository called the OpenJDK/JDK. That's the main line. That's where all main development is going on. And whenever you do a major release, like JDK 25 or 26 or 27, which will come in the fall and stuff, these are being released from branches, stabilizing branches in this main repository. And you get a new release every 6 months. Once that is released from, once you have a major release, however, development moves to a versioned, separate versioned JDK repository. So you will have typically OpenJDK/JDK25.u or 25u, or OpenJDK, JDK 26u, etc. And all the dot releases that come afterwards are released from these branches, or from this repository. This makes it a bit more complicated when we want to kind of do the releases for BSD as we're an auto-tree repository, or auto-tree import. So it's what we have to deal with at the moment. I mentioned that OpenJDK is written largely in Java, which means you need a working OpenJDK to build the OpenJDK. And that's what we call a boot JDK. The boot JDK needs to be JDK that's either the same version or the version before the one you're trying to build. So you can, if you already have JDK 25 installed, you can use that to build JDK 26, for example. And how this works is that the boot JDK actually builds a very minimal build JDK as part of the build process, and then the build JDK is the exact same version that you're trying to build properly, and you're using the build JDK to build the actual final JDK version that you're going to do. It's possible to specify the build JDK directly if you want to, so that can be a bit complicated. But when there's no existing port, what do you do? There's essentially 3 options. Cross-compiling, there's something called devkits, and there's a rather hackish trick where we can forward JDKs over SSH to a separate machine. Cross-compiling is, if you can do it, that's the easiest. But it has some requirements, and it's not really that easy. But if it works, that's the easiest way to do it. You can just specify, like here, a different OpenJDK target architecture, and if all the dependencies and everything you need is installed, then you should be good. Officially, it's only supported on GCC and a handful of Linux distros. And this is where the 0 variant that I pointed to earlier is getting useful, because it allows you to build without kind of having the target architecture assembly in place already. I've not had any luck with doing this on FreeBSD using client or GCC. I've tried a bit, but it's too many loose ends. So there's something called DevKits, which is essentially just pre-made cross-compiling setups that you can download and install, or you can even build them locally on your own from the source stream. But again, officially only supporting Fedora and Oracle Linux. It shouldn't be impossible to expand that support, but I've not looked too much into that. So the method has been used successfully on BSDs before. Is this secret trick that I don't know who came up with it, but I think Kurt Miller was quite instrumental in it. What this means is we create a stub with JDK that is essentially just some of the important JDK binaries, but we replace the binaries with a simple shell that forwards the connection over SSH, like seen in the example here. It's dirty, but it works because the only goal of the JDK or the Java is to produce the class files, and the class files are architecture independent, so they can be used on the target machine. Again, I've not been able to do this. I was trying to create a new boot JDK for OpenJDK 11 on ARM32, but I think the problem is actually that OpenJDK 11 doesn't really support ARM32 anymore. So yeah, upstreaming. It's more juggling of repositories. Of course, as I mentioned, the mainline OpenJDK repository is what we're sourcing into our port, the Battleball JDK repository. This is kept in sync continuously, and whenever there's changes, breaking changes, or something that we need to port from the upstream project, that's being done. And this is where we're running CI using GitHub Actions with a virtual machine inside to run FreeBSD and OpenBSD, both compilation and tests. One of the problems here is that since the virtual machine in the GitHub runner is so slow, we're not able to emulate a different architecture, so we're not able to build or test the ARM64 port, which is a bit bad, but what we have to work with. So what we're doing is that we have gotten a separate OpenJDK BSD port repository, and we try to find like logically coherent patches that aren't too big, so that it should be easier to review, and we move them over to this OpenJDK BSD port repository you see on the end. And the idea is that every pull request that we try to merge into that should be reviewed by at least one upstream reviewer. And during that process, the patch of course changes a bit, and then we have to port those changes back into the Battleball repository again. But the reason we do this is that at some point in the future, our goal is to merge the entire difference between the BSD port and the upstream repository in one pull request. And that will be a big diff. So if all the different parts, all the different partial diffs are being reviewed, have reviewed by an upstream repository or upstream reviewer, then the confidence they have for that merge will be much bigger. There will still be nitpicking and probably changes that has to be done, but it will be a much more smooth process than if we just come with like, oh, here's 10,464 lines of diff, please review it. So, wrapping up, the main challenges of the project is, of course, the complexity. OpenJDK is itself is a really complex code base. It's essentially an operating system running on top of an operating system. It interfaces with mostly the low-level operating system primitives of the target platform, which means like memory handling, process handling, threads, debugging, system information, scheduling, all of that stuff it goes down pretty low. That means I also have to learn quite a bit about how the target operating system, in this case FreeBSD, is doing these things. And sometimes figuring out what are the subtle differences between how does FreeBSD load shared objects compared to how, for example, a glibc-based platform like Linux is loading shared objects, and why are the symbols visible in this one case but not in this other case. It's a lot of finicky stuff that you have to go through. Another challenge is, of course, that upstream sometimes breaks our port. It's not that often anymore, but it still happens, and then we have to do it and work on it. For the most part, this is because macOS thinks it's BSD, and they interfere with the stuff that we thought we had settled, but that's just how it is. As an auto-tree port, that's what you kind of have to expect. And of course, that the GitHub actions don't natively support BSD, that is a challenge. And we are trying to push on Microsoft to fix that, so that hopefully someday, we'll see. The future, OpenJDK and FreeBSD is in a pretty good shape, especially the upstream port, or the mainline port. But it needs to be maintained, and there will be some continuous work doing it. I would say the work is not done after the code is upstream, but the BSD project will get a slightly different role. We'll then probably get more involved in changes as they're happening, instead of kind of getting them after we try to merge something that has broken apart. That gives us better resilience against breaking changes, but there's also an expectation from upstream that we will continue to maintain the port and have the resources to keep it up to date. And conformance certification is a process that will probably have to be repeated for new versions. I'm not entirely sure how that works, but that's what we're going to figure out. So, big list of thanks. Of course, the FreeBSD Foundation, very important, because without them it wouldn't be possible to do this work. The BSD porting team with Greg Lewis and Kurt Miller is being really helpful, and also it must be mentioned that the port was more or less done by these people. They have been involved like 10, 15 years or something. I've been involved in 1.5 years, so I've contributed a bit, but the port is mainly their work. And the OpenJDK project, a few people mentioned here that have been helping us with both finding our way in the OpenJDK project, but also helping with reviews and helping with feedback on how to do things and stuff. I also would like to mention my mentors for the FreeBSD port commit that I have got. Foss and Bob, they have both been really helpful, especially Foss has been really giving a lot of insights and feedback and how to be nice to the port system and how to navigate it. Piotr Kubai has been helping with the PowerPC port, or making it still run on PowerPC, and has provided bootstraps for the PowerPC builds. Ronald Flopp has been doing a lot of work lately on improving or updating the default Java version in FreeBSD. Whereas like 1.5 months ago or something, we were still on Java 8 as the default version. Now we're on Java 25. That's massive work, but that has involved a lot of forks and stuff. And of course, everyone who files bugs, who comes with comments, who has an interest in the project, who sends email or mails to the mailing list or interacts on the Fediverse or whatever. Especially with open source project and free software project, I mean, the community is the contributors to this. There are some of us who do the code, but there's so much going around, which essentially is the important part of the project. So thank you, this is me, and thanks. Related stickers there.
And we also do have time for maybe like 4 minutes for questions. Yes.
How easy or hard was it to come up with this system of having those 2 different repositories where each merge request gets approved by one project member and all that? Does it imply some kind of acceptance already within the community that the BSD should be like a first-class operating system in the OpenJDK? And that's not always the case.
Yeah. This approach of how to do it was suggested to us by the OpenJDK project itself, and it is one that has been used for projects, other projects that have been in the same situation. As for whether they want FreeBSD as a first-class citizen or not, they seem very open to that and quite supportive. From the very first, when we started talking to them about it, and we wanted to do that, and I was presenting myself as like the one who's I have this as a goal. How likely is it that we can do it? It's like, yeah, if we just do it in the right way, then yeah, of course. And also that we are willing to support the project after being upstream. That's been very important for the upstream.
I just want to comment that a few weeks ago I was asked by some of our product people if we can do Tomcat 11 and Java 25. And I think it's the first time they asked such a question, and I didn't have to say, can you just wait a bit to see if we get this in FreeBSD? We don't have it yet. I was like, yeah, of course, it's default, which felt really good. So thank you very much.
Yeah, that thanks to Ronald.
Yeah. Oh.
More questions? Okay, thank you very much.
Thanks, everyone.